Okay, so here we go. What we're looking at is what we call the ambiguous case. It's called the ambiguous case because there's a possibility of getting just one triangle, no triangles, or we just found two possible triangles. The ambiguous case happens when you have a side-side angle. How do you know it's a bad triangle? Because the ambiguous case could also be, instead of side-side angle, you could write it as angle side-side, which is a bad word. We call it the donkey triangle, okay? So whenever you get a side-side angle, you have the dilemma of either one triangle, no triangles, or the possibility of two. So if you draw and solve for the first triangle, which we just did, there's the possibility of drawing a second triangle. To find the second triangle, here's what we do. These two sides are equal. It's an isosceles triangle, which makes these two angles equal. 44.4, 44.4. Angle B is no longer here. Angle B is over there. So to find the answer to angle B, 180 degrees makes a straight line. So I'm going to go 180 minus my 44.4, and I get an answer of 135. So angle B now is 135.6 degrees. So I'm going to put that in there. So that's 135. Let me erase that 30, because that 30 is in here. 30 is right in there. 30 is right in there. This angle is 135.6. Now, how do you find angle C? The same way we did before. Angle C is easy because how many degrees in a triangle? 180. So one angle C, it's going to be simply 180 minus my 30 plus my 135.6. So I'm going to go 180 minus my parentheses, 30 plus my 135.6, and I get an answer of about 14.4 degrees. So angle C is 14.4, okay? Now, finally, if I want to find side C, which is not all of this at all. Remember, this triangle's gone. That triangle's not there. Alex, will you stop talking so they can listen?
Yeah.
Thank you. Side C is not. This triangle's not there. So side C is just this little side here. Again, opposites. Side C over the sine of its angle equals the 5 over the sine of its angle. It has to do with opposite. Side C over the sine of its opposite angle, which is the 14.4, equals my side, or my 5, over the sine of its opposite angle, sine of 30, okay? So I'm going to multiply up. I'm going to go 5 times the sine of 14.4, close the parentheses, divided by sine of 30, and I get an answer of about 2.48. Okay, so finally, when you get side-side angle, there's a possibility of one triangle that we can solve for with the law of sines. There's even the possibility of no triangles, but the only way you're going to know is to draw these, right? The only way you're going to know is to draw these to scale. Or there's a possibility of having two separate triangles, and this one's a little bit harder to solve. Okay? All right, now, let's